Mason's gain formula to find overall transfer function of the system. What is this Mason's gain formula? So let us take the transfer function T of S is equal to, T of S is the overall transfer function of the system. Now sigma k is 1 to n pk delta k divided by delta. So what are these individual terms? Pk stands for, it is the gain product of kth forward path. So in any signal flow graph there can be any number of forward path. For each forward path we need to find out what is the path gain, which means it is Pk. And what is the delta? So delta is called determinant of the graph, and the delta goes like this. Delta is equal to 1 minus sum of gain products of all individual loops. We know what is loop. Loop is nothing but we need to start at one point, come back to the same point in the same direction without repeating any node, and that loop gain is my loop gain. So the first term 1 minus sum of loop gains of all individual loops plus sum of all possible combinations of non-touching pair loop gains. So we know what is non-touching pair. So for those non-touching pairs, see, any two loops are non-touching each other, which is called two non-touching pairs. So here the second term goes sum of loop gains of two non-touching loop pairs minus again same thing for 3 non-touching loops, 4 non-touching loops, 5 non-touching loops, and so on. So it all depends on how many non-touching pairs that are possible in a given signal flow graph. This is what delta is. What is delta k? So delta k is also delta, but it is not for the entire graph. It is for the graph after eliminating all the nodes of kth forward path. For example, in a given signal flow graph, there are 5 nodes x1, x2, x3, x4, x5. If out of 5 nodes, any given path, for one forward path, it takes all the nodes. It consists of all the nodes. So after removing all the nodes, there is no graph exist, which means your delta is equal to 1. That is, that particular delta is 1. If any loops available or any self loops available, we should take all those things and we'll find out the delta value for that particular forward path, which means delta k is a determinant of the graph. That graph is not entire the graph, the remaining graph after eliminating all the nodes of kth forward path. So we know what is Pk, we know what is delta k, we know what is delta. We just substitute all these things in the formula to find out the transfer function. Here k is nothing but number of forward paths that are available in a given signal flow graph. So to understand this problem, let us take one example. Now look at this example. So in this example, I have signal flow graph, and in this signal flow graph there are nodes available. I am assuming the nodes like this is R and the last node is C, input node and output node, and we have in between nodes x1 to x7. And for all these nodes we have connections available, right? So for this particular signal flow graph, I want to find overall transfer function. Let us see how to find. The first step is, see what are the possible forward paths available. Now from this graph it is clear, from R to x1, x2, x2 and goes on up to 7. This straight line is nothing but my one forward path. I can take this straight line and I can place here, this is my first forward path, and this first forward path take all the loop gains. Now in this, what are the loop gains? I can say loop gains are G1, I have G2, G3, G7 and up to C value. This is my loop path gain. Similarly, what are the other forward paths available? Then look at this signal flow graph. I can start from R, the x2 to x3, directly I can jump from here to x6 and you can go to x7 and C. This is another forward path. So for this forward path, if you place this forward path here, and for this forward path, what is a loop gain? You just product of all the path gain, product of all the path gains which are available. So which is nothing but I have G1 to G5 and G7. So this is a forward path. So in this particular SFG signal flow graph, there are only two forward paths. Then what are the individual loops that are available? Now individual loops are from x2 I have, and from x2 to x3 I have. So I have x2 to x3 and come back to x2. So this is one individual loop, and what is the product of loop gain? Minus G1 H1. Similarly, I have another loop like which forms from x4 to x5 and x5 to x4. This is another individual loop. Similarly, from this signal flow graph, there is another loop which we can find. How? I can start from x2, I can go to till x5 and I can come back to again x2. So what is the loop gain of it? The loop gain of it is nothing but minus G1, G2, G3 and H3. So three individual loops I have. Again from this signal flow graph, I can say this is a one self loop which is available, and this self loop is also individual loop we have to take into consideration. So that is from x4 to x4 is one self loop and its loop gain is minus H4. Therefore, how many individual loops we have? So we have got all four listed here. 1, 2, 3, 4. 4 individual loops. We already seen forward paths, 2 forward paths. So forward path, individual loops. Next is how to find non-touching pairs. So to find non-touching pairs, list the loops gains, or list the what are the individual loops which are available and their the nodes. So let us say x1, if I take x1 nodes are x2, x3, x2. Similarly L2, L3, L4, all L1, L2, L3, L4 you can list out. Then how to find non-touching pairs? Now to find non-touching pairs, first of all we talk about the two non-touching pairs. To find two non-touching pairs, compare L1 and L2, see there are any common nodes. So if you compare L1 and L2, there is no common node exist. If there is no common node exist, which means there is a two non-touching pair available. And similarly, L1 to L3 you can compare. So when you compare L1 to L3 and there is one node which is touching, that means we cannot form a non-touching pair. Similarly, L1 to L4 you can compare. When you compare L1, L4, yes, so L1 is here and L4 is here, therefore they are two non-touching each other. We will get one particular non-touching, two non-touching pair. Similarly, you can compare L2, L3, L3, L4, all possible combinations you can compare, you can come up with two non-touching loop pair combinations. So for this problem, from looking at all these things, you can say even L1, L2 is one combination, and L1, L4 is one combination, and L2, L4 is one combination, and L3, L4 is one combination. These are the four combinations we get for two non-touching loop pairs. Not only for two non-touching loops, we also look at three non-touching loop pairs. Means first L1, L2, L3, look at do you have any common node. If you don't have any common node, then we say all three form three non-touching loop. And L3, L4, L4 like this, all possible combinations we can look at, and from that it is very clear L1, L2, L4, these three loops combinedly form three non-touching loop, which means those three loops don't share any common node. So we have got forward paths, individual loops, and two non-touching pairs and three non-touching pairs. So we just substitute all these things in the Mason's gain formula. So for this particular signal flow graph, then what is the formula? We can write the formula it as T of S is equal to, or else C of S by R of S is equal to, we know already there are two forward paths, therefore in numerator you will get delta 1 G1 plus delta 2 G2, let us say G1 G2 are your forward path gains divided by delta. So delta we know already, delta is equal to, you can write here delta is 1 minus sum of all non-touching pairs. What are the sum of all non-touching pairs? We got all four non-touching individual loops. So first of all, we'll take individual loops. 1 minus individual loops are L1 plus L2 plus L3 plus L4 plus 2 non-touching pair combination. We have 4 possibilities again, all L1 L2. We have L1 L4 and L2 L4 and L3 L4 minus 3 non-touching loop pair combination, that is L1 L2 L4. So this is what the delta is. This delta is the denominator. It is also called the determinant of the graph. What are the numerator terms? Numerator terms we have P1. P1 means, other we can say G1. G1 delta 1 plus G2 delta 2. What is G? We already got G. G1. What is delta 1? So delta 1 is the determinant of the graph after removing all the nodes of the first forward path. So if you remove all the nodes of this first forward path, no loop exists. When no loops exist means your delta 1 value is 1. Similarly, for a second forward path, if you remove all the nodes of the second forward path, look at, do you have any individual loops available? So if you look at this one, this is what you have, second forward path. If you remove the nodes, there exists one loop. So that loop is nothing but L2. So what is delta 2 minus? 1 minus L2. There is only one loop, so there is no possibility of non-touching pair. So delta 1 is 1 and delta 2 also we got this 1 minus L2. Then we already got delta. So if you substitute all these things here, then you will get the transfer function T of S. So your T of S, you can write it as, numerator is delta 1 we know. So the delta 1 is 1, G1 we know. From using G1 we can find out the transfer function very easily.